Hello everyone. What I'd like to do in this video is talk about one of the most famous theorems in mathematics, the Pythagorean theorem, which relates the three sides of a right triangle. Let's go ahead and draw a picture. So here I have a right triangle. That means that this angle right here would be 90 degrees. And let's label these three sides. So let's call this side here A, or the length of this side will be A. The length of this side will be B, and the length of the longest side will be C. Now, oftentimes with a right triangle, the longest side of the right triangle is called the hypotenuse, and the two shorter sides are sometimes called the legs of the triangle. Now, what the Pythagorean theorem does is it relates these three sides together, and what it says, famously, is that a squared plus b squared is equal to c squared. Now, geometrically, let's think about what this is really what this is saying. When I think about geometrically, when I think about a number being squared, I'm always thinking about the area of a square. So if I go ahead and draw a square over here with side length A, the area of the square will be a squared. If I draw a square with side length B, that means the area of this square will be b squared. Now if I think about a square with side length C, the area of this square will be c squared. So what the Pythagorean theorem says geometrically is that the area of this square plus the area of this square will always be equal to the area of this square. What I'd like to do now is give you a quick proof of the Pythagorean theorem. So don't be scared, it's very accessible. So to prove this to you, I'm going to draw a picture. Let's take one square. We're going to kind of draw it kind of slanted. And let's say that the sides of this square, we'll label them C. So now what I'm going to do is I'm going to take another take another square and put this smaller square inside of it. So now within this bigger square, I have a smaller square and four triangles that'll all be the same. Let's call the length of this side from here to here, we'll call this A. And let's call this length from here to here B. Now since all four of these triangles are the same, that must mean that this length must also be B. This length here must be A. This length here must be B. And this length here must be A. Similarly, this will be B, and this will be A. So now what I'm going to do is I'm actually going to think about the area of this larger square in two different ways. The first way to think about it is to just think about the larger square and think about its side length. So the area of the larger square, this side length, will be A plus B, so that the area of this larger square will be A plus B times A plus B. Now, an equivalent way to think about the area of this triangle is to break it up into smaller pieces. So let's say that the area of this square here, that'll be the same thing as the area of this smaller square plus the sum of the area of these four triangles. So the area of this smaller square will be c squared. And since all four of these triangles are the same, I'm going to have four of those, and the area of one of these triangles will be 1/2 base times height. So 1/2, I guess the base here would be A, and here the height B. So let's clean this up here a little bit. On the right hand side, we'll have c squared plus, I have a 4 times a half, which will give me 2ab. Over here, all I'm going to do is FOIL this expression out. So I'll get a times a, I'll get an a squared, I'll get an a times a b, I'll get a b times an a, and then a b times a b. So since order of multiplication is commutative, b times a is the same as a times b, so I have an ab here, another ab here, so I have 2 ab's. So I'll have a squared plus 2ab plus b squared will be equal to c squared plus 2ab. Now, try not to get too excited here, but notice that if I subtract 2ab from both sides, these cancel out, and I'm left with one of the most famous theorems in mathematics, that a squared plus b squared is equal to c squared. And there you have it, the Pythagorean theorem. I hope you all found this helpful. Take care.